I usually do it. Until next time, bye!
So grade 11s, we are looking then at graphs. The worksheet that you have in front of you is based on core level. You must go up to extended level, but I think let's first do this worksheet and make sure that you understand it before we go over to more difficult ones. I just want to go at the background here of graphs. Let's just look at that, the background of graphs. In the first place, we're working with a straight line graph. This is the one y is equal to mx plus c. And we need to understand what is the meaning here of the m and the c. So if I draw a graph, there's my straight line graph, then this is c. C is the y-intercept. That is where you cut the y-axis. M is your gradient. The gradient is the slope that we have. If it is a positive gradient, it looks like this. If it is a negative gradient, the slope looks like this. So that gives you the slope. The meaning of M is, we say it is delta y over delta x. Delta means this length, the vertical length, and delta x means the horizontal length there. So here on the graph, this is delta y and this is delta x. That's how we will read it off. So we need to understand that. In the second place, we have a parabola. You must be able to draw parabolas. The Parabolas equation is y is equal to ax squared plus bx plus c. That is the typical parabola. Can you see the quadratic equation here? Now, you can have a shape like this, which has a minimum turning point, and we can have a shape like that, which has a maximum turning point. A minimum and a maximum turning point. And this A here determines that. So if A is positive, it is the minimum. If A is negative, it is the maximum that we deal with here. And then in the third place, we're going to draw hyperbolas. And the hyperbola equation is y is equal to a over x. And again, if A is positive, then it lies in quadrant 1 and 3. This is 1, 2, 3, 4. Or we can have y is equal to negative a over x, and then they will lie in these quadrants. You must be able to identify these graphs. You must know which one is which one. They ask questions like that. Now, if we go back now to the straight line graph, y is equal to mx plus c, then we also know if I have two graphs looking like this, and there's two parallel lines, then we can say the gradients are equal. So they are parallel, then your two gradients are equal to each other. Then it like a railway. But they can also be perpendicular. And then we say they are perpendicular if M1 times M2 is equal to -1. Okay, but we'll go further with that information later on. Okay, so let's look now at the worksheet. You will see this is on core level, but let's first make sure that you understand this before we go to the more difficult ones. The first one says, which word describes the correlation in the scatter graph? Now, this is a scatter diagram. You get it in biology and science as well. And we cannot draw a straight line there. So what we do is we just draw a line in the middle, fitting right in the middle. But you can see from the slope that this is a negative gradient, that it has then a negative gradient there. Right. The second question, now whenever we work with graphs, the scale of the two axes are very important. You can see they differ. It's totally not the same for the distance and the time. So we first need to find out what is the scale. Now if I look here, then I have 4 blocks there. 60 minutes in an hour divided by the 4 means that each little block represents 15 minutes. And on my vertical axis, I have here 2 blocks representing 20 kilometers. So that means 20 divided by 2 is 10. So each little block here is 10. And each little block on this axis is 15 minutes then there. Okay, that's what you, yes? Oh, that's what I asked right at the beginning. Have they done this? So where should we start then? At question what? Question 4. Oh, okay, then we move over. Sorry. Question 4. Haven't we done this one also? Question 4. Okay, so let's then look at question 4. But I think we should slide on. It's not this one, it's the next one. Yeah, there is that one. Okay, now this is a very nice example then of a parabola, precisely how you are going to do it. If you look here, you can see there is my equation for a parabola. And I can immediately see my shape is going to be like that because there is a positive there. So to be able to draw your graph, you need to complete the table first. And we complete tables with substitution. So we're going to start then here substituting this value in x's place. Make sure that you use brackets because otherwise you're going to get the wrong answers here, -3. So you can take your calculator now, press your calculator, brackets, -2, close the bracket, squared, -2, brackets 2, close the bracket, -3 is equal to. And what is the value that you get in there? A 5, yes. So this one is then 5 there. This one, 0, this is still your C. So we can immediately just use that value and write it in there because that is still your y-intercept, ax squared plus bx plus c. And the last one is now this one. So we substitute the 5 now in here. A 5. Sorry. So now we substitute 5 in there. Again, you can press your calculator, brackets, a 5, close the bracket, square, look that the square should be outside that bracket, minus 3 times 5 minus 3. And what is your answer for that one? What do you get? 12, yes. So now we can plot the points. From there, you plot your points on your graph now. So the first one is negative 3, positive 12. The second one, negative 2, 5. It should be here in the middle. Negative 1, 0, cutting the x-axis. 0, negative 3. There's that point in there. 1, negative 4. This is the turning point that I will find there. 2, negative 3. There. Here it cuts the x-axis again at 3, 0. Then the next one is 4, 5. And the last one, 5, 12. So I plot my points. And now you have to draw this curve with a free hand, not with a ruler. Make sure that you go through the points. When they mark it, that is important, that you should go through the points. And it just takes a little bit of practice to get them nice and smooth. So there is your parabola. Plot the points and draw the curve. You can rather wobble a little bit than pick up your hand. It must be a smooth one that we draw there. Right, have you drawn yours? Okay, now, and that is what you're going to see on the extended level. The graphs that we still have to do is the questions. That is usually a bigger problem to answer those questions. Now, the first one says, use your graph to find the solution. Now, if we go back, we will remember we said y is equal to this. So y is the parabola that you've been drawing. So this means that this value here is actually y. And we have to find the answers where y is equal to negative 1. That's where we will find those answers. So the best thing to do is to draw a line on your graph where y is negative 1, which is here. So I'm going to draw a line there across my graph. This is the line y is equal to negative 1. And you will read the solutions now off here. There where your parabola and this line y is equal to negative 1, where they intersect. That's where we're going to get the answer. They also say to 1 decimal place. We have to round it to 1 decimal place. There's 2 solutions there. So it is, I read mine off at negative 0.8 and at 2.6. You might differ a little bit. So negative 0.7 and negative 0.9, 2.4, 2.5, 2.7. We will still accept that as the correct solution. So you might differ a little bit there. See if you can read it off. But this method of drawing that line works very nicely. And you're going to get a lot of questions looking like that then. Okay. Now we go to the second graph, but we're going to draw it on the same axis. But first we have to complete the table. And immediately I can see that this is a hyperbola. That's the third kind that we've learned now there. So the shape is going to be something like that. Again, we have to complete the table, and we do that with substitution. So in the first place, we're going to substitute in x's place 0.25. So on your calculator, you can just say 2 divide by 0.25, and the answer is, what do you get? 8. Yes, 8. This one is easy. 2 divided by 1 is 2. And there's my table. So now I have to plot these points on the same axis. On the same axis, you have to plot those points there. So the first one, again, we'll have to look at the scale here. Here's 5 little blocks. and actually representing 10. So 0 point, each little block represents 0.2. So you must be very careful now where you plot those points. And this one is at 8, so it will just be there after that one. Then a half, which is in the middle, a half 4, and 1, 2, 2, 1, so there in the middle, and then 3, 0.7, 4, a half, and the last one, 5, 0.25, which is there. And now I can join those points again with a smooth curve. So this is what you shouldn't do here. It shouldn't look like that. Oh dear. Yeah, it's not so easy to rub it out now there. So there is your hyperbola. So the two graphs are intersecting there now here at one point, which is this one. Okay, you can plot your points. There they say on the same grid, draw it. Look at this. This is also the same as the table. So we don't just draw the lines, you draw it between those limits. Don't extend it, because again, then you lose a mark. And then the last question says, write the x-coordinate of the point of intersection. And that is now where those 2 points intersect, and I find it at x is 3. That's where my point is lying. Okay, a nice question to look at everything. Are you finished? Okay, right. Then we go over to question 5. Now this time we have question 5, there you are. This time it's a straight line graph. It's actually two straight lines that we have now on top of each other. They give you two equations. 2x plus 3 is equal to y, and also y is equal to negative x plus 2. Now, this one is in standard form. What is standard form? Y is equal to mx plus c. That's your standard form. So we need to change this one, otherwise we can't compare the two graphs, because we have to look now which one is which one here. So if I change, actually both of them are in standard form. Sorry, it just reads from the other side. So y is equal to negative x plus 2, and I changed the original one now here to standard form. It was 2x minus y is equal to 3. The sign here must be minus, changing it to standard form. I took the y over because I want y to be positive then there. Now, if we look now at these two graphs, this one, your c value here is 2. And in this case, the c value is negative 3. So if we look at this graph here, there's the negative 3. So that's how I know that this line that we have here is 2x minus y is equal to 3. So that's my first answer there. You can write it in standard form or in the original one, 2x minus y is equal to 3. That is then that line. But you can see from the standard form, that's how I change it. So we can also write here 2x minus 3 is equal to y, and then we can easily see why we choose that one. Now they say, find the gradient of the line on the grid. Now I can read off the gradient, but I can also see it in the equation. So it doesn't matter which method you are using. So if we look here at the standard form one, what is the gradient? This is m. Y is equal to mx. M is the gradient, not the x, only m. So the gradient is going to be 2. Or you can even write 2 over 1. That's the same thing if you want to write it like that. Let's look on the graph. we said the gradient is delta y over delta x. So if I draw a little triangle now here, we do it where we have nice points, not cutting in the middle of blocks, but on a nice position. Can you see that this delta y is 2 and delta x is 1. Rise over run, delta y over delta x. So this is my gradient there. Then they say, complete the table below for the other equation. Now the other equation is this one. I'm going to use the standard form one, negative x plus 2. That is the standard form one. Very easy. Just make sure that you substitute correctly with your signs. But so we have to say negative 1 plus 2. You can do it on your calculator. Okay, so what do we get? The brackets are vitally important. Otherwise, you're going to have wrong answers. Negative, and then brackets negative 1 plus 2 is equal to. Okay, and my answer is 3. Again, here we have 0. 0 is the y-intercept, and this is c. So you can immediately write that one in there. We don't need to calculate it. It just will fit in there. The next one is a positive 1. So negative 1 plus 2 is then 1. If we substitute a 2 in there, negative 2 plus 2 is 0. And if you substitute the 3 in there, negative 3 plus 2 is negative 1. So we must make sure that our table is correct to draw it. So now we're going to draw the line on the grid. And it is the negative x plus 2. So I can just plot all those points. Negative 1, 3, 0, 2. So there's the y-intercept of this one. 1, 1, 2, 0, and 3, negative 1. And I draw this with a ruler. It must be a straight line with a ruler. You must draw them with a ruler, a ruled line there. So there's your second one. And the last question says, use your graph. That means you need to read it off to find the solution of the two equations. And the solution is there where they intersect. So this is this point that we're looking there where the two graphs intersect. That is my solution that I'm going to read off. And mine is 1.6. Again, you may have 1.5 or 1.7. It might differ a little bit. This one shouldn't be too difficult to get the correct one then there. So this is a straight line graph. Right. Now, again, we have a parabola. Because there is a negative here in the front, I immediately realize that this parabola will have that shape. Remember, they must be symmetrical. So if you find a point that's out of the line, you must know there must be a mistake somewhere there. How do we complete tables? We substitute. So if we substitute then in here now remember it's negative. And then negative 2 squared, look there, where's the brackets? The square outside, plus negative 2 plus 2. So again, let's take our calculators and press them. Negative bracket, negative 2, close the bracket, squared, plus, again a bracket, negative 2, close, plus 2 is equal to. And what do you get? I hear. What is the answer? Negative 4. Negative 4. Yes. The next one that we need to substitute is the positive 3. So I change it to positive 3 there. Again, press your calculator. Negative bracket 3, close the bracket squared, plus bracket 3, close, plus 2. And what do you get? Yes? Come on, somebody. Will you give? Yes, it's again negative 4. That's right. Okay, and the last one is now the 4 that we're going to substitute in there. So let's put a 4 in there and a 4. And what is your y value? So the table gives us the points to plot. What do you get? I hear some negative 10. Okay, negative 10. If you get different answers, it means you're not pressing your calculator correct. Look at the brackets and the square outside, otherwise it will be wrong. Right, now we can plot the points. So the first one is then negative 3, negative 10, which is here. And then negative 2, negative 4, negative 1, 0. This is the the x-axis where you cut the x-axis. Then the next one 0, 2. There we cut the y-axis. 1, 2. There's another point. 2, 0. Again the x-intercept there. 3, negative 4. And the last one is then 4, negative 10 here. Okay, so now we can draw the parabola. Again, I join the points with a free hand, making sure that they go through the points. Look at this one. Don't cut his head off. It must go round there. And there's my parabola. Joining it with a smooth curve. No rulers. No rulers. It must be a smooth curve that we draw it. Also, look at this one. It's not a straight line there. You must draw that curve at that point there. Okay. Now they say draw the line of symmetry. The line of symmetry will be exactly here in the middle. And we draw that line with a broken line. You use a broken line to draw the line of symmetry. Right in the middle here. It will be where x is a half, where you will draw that one. They can even ask you the equation. They didn't do it now, but they can ask you the equation, and this will be where x is a half. Remember, I cut the x-axis. That's why this line's name is x is equal to a half. Then they say, use your graph to find the maximum value of y. Now, the maximum value of y is this one. And that's why I said you have to draw it round, because the answer is not 2. It's higher than 2, because we must make that curve there. Now again, look at your scale. There's 5 tiny little blocks to form a 1. That means each little block represents 0.2. So this one should be 2. I got mine at 2.4. Mine is at 2.4. Again, you might differ a little bit. 2.3 will also be correct, but not 2. 2 is wrong because it must be higher. Then they say draw the line y is equal to 1 on your grid. So this time they even tell you to do this. This is the line here that we're going to draw with a ruler. Y is equal to 1. Draw that line. Y is equal to 1. And now they say, look at the last question. They say this is where your parabola and this line intersects. That's what they want there. So this is these 2 points. That is what we're going to give as an answer. There where my 2 points intersect. But it's very nice to draw that line. Even if they don't tell you to do that, then it's good. And so here, can you see? This is where the parabola and that line coincides or solve simultaneously or intersect. And my two solutions here is negative 0.4, and there it is 1.5. 1.5. Okay. The next question is then, are you finished? Sorry? Oh, is it at the end of the period? Okay. Right. Thank you. Thank you. Mr. Mazungosi, shall we continue with the grade 12s with this worksheet?